If we give you, it's the first property, if you have b to the x equals 2y, that's an exponential function. You can actually change that back and forth. You can go back and forth between these two. You can exchange it to, if you do the inverse of that, you get the logarithmic function, which says log y base b is equal to x. So you can go back and forth. As I said, you can write that log y base b equal to x. You can change it to y equals b to the x. That's the first property. I'll put this aside for now. If I came in and said, give me the answer to this. No, you didn't even tell me what the log is. Well, rule number one, it says when you have a logarithmic function like this, you can change it to exponential. It says you can change that to 25. I should make this 5 actually, not 2. 25 equals what? 5 to the power of x. 5 to what power is 25? Isn't it 2? So x will have to be 2. If you look at your calculator, there is no log base 5 on it, unless you got one of those fancy ones you can type in the base. But most calculators have 2 bases, log base 10 and log base e, and that's it. We can find the log of any one, log 32 base 2. Yep. Change of base is called. Yep. Oh no, there's actually, you don't even need that. There's a change of base. Log 32 base 2. I can change that to 32 equals 2 to the power of x. 2 to what power is 32? 5. So if you have a calculator that does log 32 base 2, you plug it in, I bet you end up with a 5. Log 81 base 3. You can say 81 equals what? 3 to the power of x. That means x will be what? 4. Log 100. If there is no base, it's assumed to be what? Base 10. Common log, that's. So if you don't see a number, that's assumed base 10. And that becomes what? 100 equals 10 to the x. X will have to be what? 2. If you see ln, ln on your calculator, there's a button ln. Of e to the 5 equals x. The ln is actually log base what? Anyone? Log base e. So we use that rule number 1, or property number 1, change it from log to exponential. I should be able to write that e to the 5 equals the base, which is e raised to the answer, which is x. Then x will have to be what? 5. So that's the first property. Well, the problem with that, if you're given a problem like this, log 27 base 4, yeah, good luck. We're saying, okay, 27 equals 4 to the power of x. Well, 4 to what power is going to be 27? Your guess is as good as mine. Could it be, nope, Yeah, could it be x equals 2.377443751? Well, how'd you get that? I guessed on it. Of course I didn't guess on it. My calculator does not have a button where I can change the base, but there's another way of getting that answer. And that's called the change of base. If you want to find the answer to this and your calculator doesn't have that, you can get the answer to that by using the log, the common log of 27 over the log of 4, or the natural log of 27 over the natural log of 4. So notice if I take my calculator and I go the log of 27, close the parentheses, divided by the log of 4, close the parentheses, 2.377443751. And if I did the natural log, the ln of 27, close the parentheses, divided by the ln of 4, it's the same answer. I don't know if you can see the answer. So you can find the log to any base on this calculator, on any calculator. So let's go back to property 1. You're going to list all the properties. Property number 2, you just saw that 2 minutes ago. Right here, it says for the log function, the domain has to be what? X is greater than or equal to 0. That means what? Can't take the log of a negative number or 0. Doesn't matter what the base is. A negative number or 0. Can't take the log of that. Third property, which is from right here. Since the graph for the exponential function always goes through 0, 1, the graph for the log function is always going to be what? 1 and 0. So the log of 1 is always a 0. Always. So the log of 1 to any base is always a 0. Property number 4. When you have multiplications, the log of base b of x times y. Remember, the log is nothing more than the inverse of exponential function. What do you do with exponents when you multiply 5 to the third times 5 to the seventh? What do you do with exponents? Add them. Well, that's the same thing. So this will be the log of x plus the log of y. And what about when you divide exponents? What do you do with them? Subtract. And power to power, what do you do with power to power? You multiply, right? So if you have x raised to the power of n here, you can take that n, move it to the front, because it becomes multiplication. And these are all the properties of the log. Few examples, then we're done. I'll leave these here for now. Simplify this, the natural log of 6x over 5. By the way, the log or the natural log, all these properties will be fine. They'll apply to it. So let me have this handy. I see I have a division here, right? Rule number 5. It says when you have division, you can change it to what? subtractions. So I can write that the natural log of 6x minus the natural log of 5. I'm going to write R5 next to it. That means came from rule number 5. Right here. Are we done? Not really. What does 6x means? Multiplication. So I can break it down to the natural log of 6 plus the natural log of x minus the natural log of 5. They came from rule number 4. When you multiply, you add that. See rule number 4? When you have multiplication, you add them. So I use the multiplication rule on this one to break it down to the natural log of 6 plus the natural log of x. Let me try another one. The book likes the natural log, everything natural log. I'll make this a log. Log square root of 3x plus 2. I don't write a base. That means base what? 10. I can take the 3x plus 2 and write that 3x plus 2 to what power? 1/2. Right? Square root means the power of 1/2. Cube root means the power of what? 1/3. So the power is 1/2 here. We have a power. What rule are we going to use here? Rule number 6. Yep, move it to the front. So if I apply rule number 6 here, I should be able to write that 1/2 times log 3x plus 2. Lauren, how are you? Rich doesn't work on Thursday. Monday, Wednesday. Yep. 1/2 log 3x plus 2. Can you break the log 3x plus 2? No, that's addition. There's no rule about addition here. So that's as far as you can go with that. One more. I'll use ln. Okay. ln, 2 letters versus 3. I don't have to write a lot of stuff there. X squared plus 3 squared divided by, I should put on a new page there, the cube root of x squared plus 1. Well, the first thing I see is what? Division. That's rule what? 5? So I can write that the natural log of the top minus what? The natural log of the bottom. Well, instead of making that the cube root, maybe I'll rewrite that 2 in one shot to what? That's power of what, the cube root? 1/3. And now we can apply rule which one? 6. Take all the power, move them to the front. This becomes 2 times the natural log of x squared plus 3 minus what? 1/3 the natural log of x squared plus 1.